Hello everyone. Today we are going to start one more session of Leetcode where we'll solve some medium level questions that we haven't solved before. And with me we have Saurabh and Chitresh. We'll solve some Leetcode questions together. So let's get started. Medium and to do. You have any preference? Any questions you guys can select?
Yeah, can we do 503 next greater element 2?
Okay, let's do it. Okay, Chitresh, you can read the question and we can understand.
Yes. Given a circular array, the next element of the last element is the first element of the array, we have to print the next greater element for every element. The next greater element of a number x is the first greater number to its traversing order next in the array, which means you could search circular to find its next greater element. If it doesn't exist, output -1 for this number. Okay.
Great. Okay, so we have a circular array, right? So let's take an example and try to understand it. So given a circular array, the next element of the last element is the first element of the array. I mean, if we have 1, 2, 1, so after this 1, we have again 1, right?
Yes, we have 1 and 2 towards, we can consider 1 and 2 are towards its right.
Yeah, like we can see, we can assume it is 1, 2, 1, then again 1, 2, 1, something like that, like a circular array. It just goes on and on. Okay, and so print the next greater element for every element. Like for this array, 2 will be greater than 1, and for 2, we don't have any greater element in this array, and for this one, the next greater will be 2, because we can see it is a circular array. So 1, 2, 1, 1, 2, 1. So for this one, we can have the element as 2. So if I do it naively, then it will be n square time, right? For every element, just check the. So we have the simple solution will be O of n into n. We just have for every element check the next element, and if we reach the end, we start again from beginning, and if we still don't find it, then return -1. If we don't find it, return -1. So we can implement this and then we can optimize it later. What do you guys say?
Yes.
I mean, I am thinking we can have one more approach to make it bit more simple. So we can make this array 1 to 1 as 1 to 1 and 1 to 1, and only find the next element for 1 to 1. And if you don't find it in this array, then you return -1, because we don't need to do it again, right?
Yes.
What I mean is, if we have 1 to 1, we can make a new array 1 to 1 and 1 to 1, and we just try to find the next greater element for this first 1 to 1.
First n number.
First n number. Yeah. So make an array of 2n size, where same, like we just concat the same array again and find next greater element for first n element. That would be my approach. You guys have any other better idea?
Yes, but like the time complexity for this will also be n square.
Yeah, it will be
But
n square.
implementation will be easier.
Exactly, yeah. It will have the same time and space complexity,
Yes.
but you don't have to worry about going the next, so it will be easier to implement.
Yes.
So time complexity will be O of n square and space complexity will be O of n, right? Because we are just storing it again. So okay, let's implement it. So we have the answer, like next greater element array, and modified array will be array plus array, like nums. Let's make the nums as nums plus nums. We'll print it so that you can see. Print modified array, and we can make a auxiliary function. Next find next element, which will take this array and index and give you the next element in the array. So for I in range of index plus 1, it's the number or index, index. So
yes,
number, so it will find the next greater element for number at index ind. Let's make it more meaningful for the users. So number will be array and index, right? And so for index, for I in range of index plus 1 to length of array, if array I greater than number, return array I, right? Like I just find the next greater element. Is that clear?
Yes.
Any doubt you guys have about this function?
Just like in optimization, like we can only check the next n minus 1 numbers.
Yeah, so like we are doing for we can do it, but it won't improve any time complexity, right?
Yes. Okay.
So let's do it simply right now and return -1. Yeah, but I will note your point, so we can just consider the next n elements, right? Right? So yeah,
Yes.
that can also be only to optimization, but that won't give us any beta time complexity. So for index in range of length of array, next getter element dot append find next element modified array, no, like next getter element, okay, and modified array and index. Okay, let's like make it maybe a bit simple. So we have the next greater element will be index, and we append this one and return element. I think this should work.
Yeah, it is nums.
Nums, okay. Okay, looks all right. Let's submit it. So it will give, I guess, timeout error because it's on n square time, but it won't show you any like wrong message, like wrong output. So we have to do it in O of n time, right? Like we have this timeout because it's taking O n square time, and the length of array is 10 power 5, so we have to do it in O of n time. So okay, how you guys do it in O of n time?
Like we can use a stack
Mhm.
to keep. We can use a stack and traverse the array in reverse manner, so
Okay.
that the maximum element, the greatest element, is stored in the stack.
Okay, let's write it down. So you can describe it here. So you have this this one and
Okay. So like I'm first considering that the array is not circular, and then we can like modify our solution to make it work for a circular array.
okay,
right?
yeah, sounds good.
So our array is 1,
Mm-hmm.
2, and 1. So at first we will travel from I equal to 2.
Mm-hmm.
So like I will write down the basic algorithm.
Mm-hmm.
Like we have an empty stack.
Mm-hmm.
So our stack is empty, right?
Mm-hmm.
So what our output should be, like if we don't consider it to be a circular array,
Mm-hmm.
like for the first element 1, its next greater element is 2.
Yes.
For the second element, it does not have any element greater than it, so it will be -1.
Mm-hmm.
And for the next element, it will be also -1, I think.
Yes.
-1. Okay. So when our array is when our stack is empty, if stack is empty, then we can say that element of ours has no maximum greater element to its right. So we make it -1. Else, if we check if the element at the top of the stack is greater than our current element. Suppose if stack.pick is greater than our element, so we will put it in our output array.
Okay.
So stack.pick, and if our element is less than this, like stack.pick is less than our array of I, then we shall pop elements from the stack until we get a greater element.
Yeah.
Like while stack.peak is less than equal to array of I, we shall pop them, and at last suppose if our stack is empty, then that element has no greater element in it.
Yes.
Or else we can say like stack.peak. Yes. So it can be understood by taking another example. Like suppose I have 4, 2, 7, 6, and 9. So at first our value of I is 4, and we should also make the stack here. Okay, so value of I is 4, and I is equal to 4. So okay, so if our stack is empty, so we put -1 as its greatest next greatest element.
Yes.
So our answer will be like all these elements will be empty, right? And also we have to put that element in the stack.
Yes. So where are you putting it in the stack?
Yes. Okay. Stack.push of array of I. So we have our stack as 9. Okay. So our next element is this 6. Index 3, the element is 6. So at first we will check if our stack is empty or not. So it is not empty. So we go by this condition. Else we check if our stack.peak is greater than this element. So we check the top element of the stack. It is 9, and it is greater than our current element, which is 6. So we into the output array we put that we put the top of the stack.
Yes. Yes.
So okay, and I think we don't have to. Okay. Now our stack becomes like 6 and 9. Okay. So next element is 7. So for 7, we will check the first condition, which is not correct. So we move to the next condition. Like here we have the top element as 6, and 6 is less than 7. So we 6 is less than 7. So we ignore this condition also, the second condition, and we run into our third if else condition. So our peak element is 6, which is less than 7. So we pop elements from the stack until we found an element greater than it. So we pop 6, and we get our stack as 9. Okay, so as 9 is greater than 7, so we put it here, and 7 is put into the top of the stack.
Yes.
Okay, so next element is 2, and for 2 we will check the top of the stack, which is 7.
Yes.
So we can say 7 is this, and we put 2 into the top of the stack.
Okay.
And for 4 we like pop the elements from the stack, and we get 7 as the output. So this will be my approach for a non-circular array.
Yes. Yeah, this should work. So maybe we can go to the other question and solve it, and then we can move to this question, right? is 1. This is the question, right? For the
Yes. Oh no.
no.
They are having 2 arrays actually.
Oh no, this is not the question. So you don't have the only one without circular? Anyway, it doesn't matter. So then how would you extend it for a non-circular array?
Okay. Because in a non-circular array, suppose this array can be made as 1, 2, 1, and 1, 2 maybe. I don't think we have to repeat for the last element.
Yes, I think yes.
For this. Okay, so this is our method.
Yeah, maybe we can put these elements in the stack before, and from the I equal to n we can do the same thing. Will it work?
Or maybe we can use our modulus operation so that we put our elements. Okay, no.
No.
So our elements
I
1
think
to 1.
What
we can-
happens if you
yeah.
put this 1, 2 in the stack, and you start with 1, 2 in the stack, and like 2, 1 in the stack, and then you start from 1 to 1. Can it work?
Okay.
Chitresh, you had some point? Yeah, go ahead.
Yeah, I think this similar stack logic we can like start from index 0 also. Instead of from end, we can start the same logic from beginning, like from index 0.
Okay.
Then we can simply like 1 to 1, like our array 1 to 1, we can make it as 1 to 1, 1 to 1.
I can describe
we
it
did
in this
earlier.
page, and you can how would you
Yes.
solve it?
Yeah. Yeah, so 1 to 1.
Let's take the second example because that gives us more clarity. Like let's take
Okay.
this 4 to 7, 6, 9 example.
Which one?
The one that
Okay.
Saurabh has taken, 4 to
Mhm.
9, 4 to 7, 6, 9.
This
Yes.
one.
Okay.
Yes.
Yeah, so I've just doubled it.
Mm-hmm.
Now I'll take one more stack.
Mm-hmm.
Yeah. So when we come to like with the very first index,
Mm-hmm.
we will insert our number into the stack.
Mm-hmm.
Or I think it will be better like if we insert the index.
Okay.
So we will insert 0 into the stack.
Mm-hmm.
Then we will move to the next number, 2.
Mm-hmm.
Now we will compare this 2 with the number which is at this index, like at the top of the stack.
Mm-hmm.
So 2 is less than a of 0.
Mm-hmm.
So we will insert this also into the stack,
Okay.
like 0, 1.
Mm-hmm. So like
We will come
also create a stack with the numbers so that we understand. So it is the index stack, and
Yeah.
also like create a one more stack where we have the numbers, corresponding numbers.
Okay.
Mm-hmm.
Yes, that will be easier to visualize.
Yeah, exactly. Stack 2 will have
So then we have 4, then we have 2.
2. Okay.
Yeah.
Mm-hmm.
Now when we come to this index 7, we will compare it with the number at the top of the stack, that is 2.
2. Yeah.
Yes, so I'll create one more. Like this will be the answer.
Mm-hmm.
So since this 7 is greater than 2,
Mm-hmm.
so we will go to its index and we will like set the answer for 2 as 7.
Yeah. Okay.
Yeah, like we will do the same process like while our this stack 2 is not empty.
Mm-hmm.
So when we come to 7, 2 is less than 7, so we set this to 7. And then we remove this number from stack, 2. Now we will consider 4. So 4 is again less than 7. So here also at index 0 our answer will be 7. Because 7 is greater than.
But don't you think that
4
will give you O of n square time complexity?
No, I guess because we will be iterating through every index like at most 2 times. We will either be inserting into the stack or we will be removing from the stack. Like 4, first we inserted, then we delete, like index 0 we inserted and then deleted.
Okay.
Yeah. So now our stack, both the stacks will become empty. Like for 4 and 2 we have got the answer is 7. So in this now we will insert the index 2, that is for 7, and so in this stack we will have 7. Now we will move further. So index 3, so we will compare 6 with the stack top. So since this number is less, so we haven't find any answer, so we will again insert 0, 1, 2, 3. So this number relates to 6. Now when we come to 9, so 9 is greater than these two numbers which are present in stack.
Okay.
Yeah, so we will do the same process for these 7 and 6. We will set the answer as 9.
Yes.
9, and then we will empty our stack. Like we will have 2 while loop iterations, and now 0, 1, 2, 3, 4. So 9 will be inserted into the stack.
Yes.
Same with 4, like 4 is less than 9, so we will insert it again, index 5, number is 4. Same with 2, because like we are having a descending order.
Yeah.
So 4, 5, 6, 9, 4, 2.
Okay.
Now we have 7, so 7 is greater than 4 and 2. So we will be removing these two numbers and set the answer for them as 7. Yeah. So these two numbers are removed. 9 will be still there. So for 9 we haven't find any answer.
Yeah, true.
4 it will be 7, and for 2 also it will be 7.
Yes.
And now we have 7 also in stack. So what is the index? 4, 5, 6, 7.
But we don't need to go, right? When we reach the end, then we can stop, or we have to do it. We cannot stop. We have to do it till the end, right? Because we might find. Okay.
Yeah, so this was index 4, 5, 6, 7. So 7 will also be inserted. 7.
Yes.
And now we'll go to next number. At index 8, number is 6. So it is again like less than stack dot top. So we will move ahead. Now we have index 9.
Yes.
Yeah, so index 9, this index 9, the number is 9. It is greater than this 7 and 6. So we can remove those two numbers and set the answer for them as 9.
9, yes.
So this will be removed, and this will be removed, and this will be 9, and this will again be 9.
9. And we just return the first n element of this array.
Yes. Yeah, we will return the first n.
Yeah, seems right. So you can share the screen. One second. I will. Okay, you can share the screen, and we can try to implement this now.
Yes, I'll share my screen. Yes, so yeah, is it visible?
Yes, not yet, but yeah. Now it's visible. Yes.
Yeah. Yes, so is it visible?
Yes, you can see it.
Okay. Yeah, so the first process is same. We have to like double our array. 1 to 1 will become 1 to 1, 1 to 1.
Yes.
So what we can do is I equal to 0, I less than n, I plus plus. I'll go to the n minus 1 index and push that same number again.
Okay.
Yeah, nums dot push back nums of I.
This.
Now we will have vector of int answer And can we just stop this process after the nth, like if after the n-1th index?
No, because we might
we can
get
have
updated.
answer.
Yeah, we have to complete the end
Yes.
and then return the
Yeah.
first n element. Yes.
Okay. Yeah. So this will be 2 star n.
Mm-hmm.
And do we have some limit on numbers, like here? Like, will all these numbers be positive?
No, it can.
Mm,
No, yeah,
No.
I think it doesn't matter. Even it's negative, it should give you the solution. But I think it's still positive because if it's negative, then it will be create confusion. -1.
Yeah, because
So,
like
yeah.
we cannot store like -1 in all.
Yes, yes. So should be positive. I think yes.
Yeah. So stack of int st for int I equal to 0, or I think we can directly push the first number.
Mm-hmm.
So stack dot push nums of 0. Then for int I equal to 1, I less than 2 star n,
Mm-hmm.
I plus plus. Yeah. So let me take that example. So if st dot empty stack dot empty, so we will just, or
I think you
we
made a
can check
typo
some
in
other
line 18,
condition.
right? It should be dot. Yeah.
Yeah. Or I think we can. So why will not stack dot empty and stack dot nums of stack dot top is less than nums of I.
Mm-hmm.
So we will take the index which is at the top of stack. So it is st dot top. And we will remove this index. And the answer for this index is equal to nums of I.
Yes. Right.
Okay. Yeah. And after the while loop, we can just push the current index, that is I. I think this will be enough.
Like let's do a dry run and see if it works. Like let's take the first example and for index I, yeah, just do a dry run and see if it works.
So at the beginning we have in the stack we have 0, then I equal to 1. So while not stack dot empty, and then nums of stack dot top is less than nums of I. Yeah, so this 2 will also be inserted. So index 1. Then when the 7 comes, the answer will be, we will have answer for 4 and 2.
Yes.
Yes. And then this will be inserted. So 0, 1 will be replaced with 2. Then 7, then 6, then 6 will come. Yeah, I think it will work.
Yes. And just return the first n elements.
Yeah, so return vector of int. I think I can create one more vector, but I'll use a constructor.
Mm-hmm.
Answer dot begin and answer dot begin
Plus
ends.
Yes.
Yeah. Okay.
Yes.
Yeah, I think we can check with our example.
It's working already. Yes. We can.
7, 6, 9.
Yes. Yeah. Seems to be working fine. And
yes, we also got this. Yes.
Let's submit it. Yeah.
Passed.
Cool.
It's I also tried with my method. Like it also works. Like I just have to make a modulus of n in some cases. Like everything else is the same logic.
Okay. Okay, fine. You can also try it, and if it works, then you can also
Yes,
write it in the
It
tutorials.
worked actually. Yes.
Yes.
It worked.
Okay, so what time is it now? It's